Today's speakers are Faraz Siddiqui and Randy D'Souza. Faraz Siddiqui is a Senior Solutions Engineer and a product lead for the Enterprise Access Application Access product here at Akamai Technologies. Previously, Faraz has served as the Principal Sales Engineer for Soha Systems, which was later acquired by Akamai. He served in a technical marketing and engineering role at F5 Networks, Cisco Systems, and Alcatel-Lucent. Faraz holds an MS in Electrical Engineering from Wichita State University in Kansas and a BS in Computer and Information Systems from NED University of Tech in Pakistan. Randy D'Souza is a Senior Solutions Engineer also at Akamai in the Enterprise and Carrier Division, focusing on security and performance products behind the firewall. Randy previously worked on Akamai's cloud networking efforts and with our OEM partners such as Cisco and Riverbed, looking after technical and sales enablement. Prior to Akamai, Randy was with EMC Corporation, with responsibilities including pre-sale support and bug fixing on the back recovery and archive product lines. Randy holds an MBA from Northeastern University and a BS in Computer Science from the University of Massachusetts, Lowell. With that, let's get started. Faraz and Randy, good afternoon and welcome.
Thanks, Rob. I appreciate everyone taking the time to join us today. We hope it's a lively discussion and that you are able to learn a lot, if nothing else, be entertained. We are going to talk about the Enterprise Application Access offering here at Akamai and discuss with you first the setting of why it is important for remote access, the security posture, and the complexity that goes into that. And then we're going to dive into how it all works, where it ties together, not only from a technical perspective, but then tie it back to initiatives that are in line with businesses. Be able to keep in touch with the relative standing for where your organizations are not only today, but where they're going in the future. So we'll dive into all of these components and certainly bring up your thoughts and questions. Certainly feel free to use the chat window as we engage in the discussion. So without further ado, let's dive right in. First, I want to discuss and give a setting for remote access. And to begin with that, let's just take a step back and look at what infrastructure and what enterprises, organizations are going to look like today. So as many or just about all of you know, businesses have come a long way from the days when a few remote users needed to access a handful of applications. They may be various things. And today, same applications can live not only in data centers as they historically have, but in places like Amazon or Azure, maybe even an IBM. And ultimately, they can exist anywhere on the internet as the world evolves, as measures go off-prem, and costs are looking to be reduced. So when we take that into consideration, who really needs access to these? Well, for some applications, it might be employees. That's a historical usage. For others, it might be third parties of various stakeholders. In fact, more and more companies have a number of contractors, consultants, franchisees, a variety of other third-party non-employee use cases that need access to enterprise applications. Here's the rub, though. Not all of these users have or really even need access to the same applications. Okay? So the IT teams, many of you on the phone with us today, have taken into account the combination of user groups, maybe application groups, and then the implementation of what those look like. So the right controls and the ability to be able to ensure the right users are only able to access the apps that they're allowed to, that can be burdensome and in some cases very time-consuming as well as cost inefficient. So as you can imagine, particularly in a mobile world first, when putting in the cloud infrastructure on top of that, when you want to focus on applications firsthand, the world can be quite a bit challenging. Certainly, it's going to get more and more in that direction as we evolve. So when we put that into context, let's look at what access actually is. And that's going to mean different things to different people. Who are you trying to give access to? Maybe it is just internal employees, as I mentioned beforehand. In some cases, it goes beyond that. And in fact, most of the time in modern day, third parties are the main concern here, certainly from a security perspective. Then you want to consider, if it's these third parties, what applications specifically do those entities need to have access to? Maybe you only want them to have access to 1, 2, 5 applications. Maybe they need access to a full suite. For how long? That's another consideration to take in mind, right? You may have contractors that your companies interface with that you only need to do business with for maybe 1 or 2 months. Maybe it's much longer, anywhere in between. Well, when you take that into consideration, there's a lot that goes into play there, and you have to be able to accommodate for those constraints. Lastly, what actions can be allowed for them? Are they going to have unfettered access to the network? Do they really only need to access, say, a SharePoint site? Maybe it's somewhere in between. Right? When taking in those considerations, a lot goes into that. Then when you have to, if you want to make it secure, but you also want to make it simple, it can often be difficult. So that's when when we look at the various components for building this out, we are going to establish an omnipresent world. As I mentioned beforehand, perhaps you may need to consider mobile users, you may need to consider cloud environments, and certainly within both, you may have to consider third parties. And when that's done, traditionally, there are many exceptions that have to be built in to architecting that infrastructure, right? So often, you're going to have to punch a hole in the firewall. Some of you on the phone, and I dare say most, may have to use tools like a VDI or a VPN. And for those of you who do, maybe that involves client software and being able to protect your environment when that comes into play for controlling the network access involves many complex configurations. Perhaps that means linking together various delivery controllers. Maybe you want to plug that into a next-gen firewall. Perhaps you want to add in next-level multi-factor authentication on top of what you've already built out for a data center security system. Well, there are a lot of pieces that come into play there, and when piecing them all together, it often becomes very complex, right? So when that happens, you end up, when you open the firewall, you create your demilitarized zone. And you have, say, various products that are all pieced together for their individual needs. And when that happens, that means you have to update, you have to consider interaction, and you have to consider seamless availability while still maintaining your business objectives. So when, for example, for those of you who are moving to the cloud and you are considering moving some applications there, as well as other assets, well, that all of a sudden becomes a struggle because you have to contend for various other pieces to be maintained in the environment. If you want to maintain that demilitarized zone, and then you're still going to give your users access to the network, what does that mean for your business? What does that mean for the design of the various architectures, right? So these are the questions that we wanted to set the scene for and how to address them. On the screen here, you'll have a particular client. They make a connection inbound to your networks. Right? In order for that to happen, you open up some ports. You may whitelist some IPs. You may whitelist some general paths. Maybe they're out over the internet, maybe not. Maybe they are, as I mentioned beforehand, using a VPN infrastructure, maybe using a VDI. You guys might be using other tools and other architectures to make this happen. But most of the time, it's going to look something like this. And when that happens, you are giving network level access to the end user. And we're going to go into some of the downsides that can present, not only from a security point of view, but from a management point of view. Faraz is going to dive fairly deep into that and hopefully enlighten us. But just to give you food for thought when this happens, a lot goes into play here. What Akamai wants to do is remove all of this from your architecture and offload this to the cloud. We'll show you what that looks like. To consider when you design the demilitarized zones, keep this in mind. This is some research that we have done over the last couple of years, right? And what is found is when designing networks to allow for this inbound access, when you give end users access directly to the network, well, even if you have a seamless and well-architected site mindset when you set this up, well, there are a lot of pieces that go into that, and we found that there can be up to 14 network and application components to build out that architecture. When you think about troubleshooting, when you think about logging, when you think about auditing, that is a lot of different pieces where things can go wrong and where you may have to look for insight to solve all of those problems, right? So if you need to provide logs for a certain user, you need to do a report on, hopefully none of you, on a data breach of some kind. If you need to look for improvements on performance, some things to keep in mind, as a lot of pieces that can be managed. When building this out, a lot goes wrong. These data breaches that do occur, we all have to be cognizant that they do happen. Let's not be naive here. They happen most often when third parties are involved. So when you consider that to be put into play, and when you want to have them, your end users, be provided verbose application access, and when you want to control what those, which applications that user or group of users has access to, it can often be time-consuming. It can often be costly from a monetary perspective, and it can be very time-consuming to maintain. If any of you do currently maintain your networks or have done so in the past, I think you can appreciate what it's like managing a firewall, what it is like managing an application delivery controller, managing a really awesome but robust and sophisticated load balancer. Many of these pieces come into play. The nice thing about the EAA solution is that you don't have to punch that hole in the firewall. You don't have to worry about the various complex configurations. You don't have to install client software on the ends. You don't have to allow for lateral movement within the infrastructure. The end users are provided verbose application level usage and provisioning to your various applications. So if user A wants to applications 1 through 5, you want to have user B have access to applications 6 through 10, and so on, you have that creativity and you have that ability to be able to do it from one central repository right from a management cloud out over the internet. Very seamless, very effective, and most importantly, certainly to think about, it's very simple. So these are components that we're going to dive into and give you consideration from a technical perspective. The other piece to consider is when you provide remote access, the architectures that you currently have today, we are fully understanding that, hey, this is great. I can't just pick up and drop what I have already committed to. And often today that could be VPN. Hey, here ourselves at Akamai, we had the same problem, right? We have historically looked at what challenges might be faced using technologies like a VPN when we provide not only our internal employee access, but certainly third-party access. And the complexity that comes in to be able to design those environments when we get into hybrid environments. Right? So as I mentioned beforehand, when you consider moving to the cloud, when you consider having a seamless transition to account for not only a data center build-out, but a cloud build-out, what does that look like? what is your business going to look like when you have to purchase further software, when you have to consider these hybrid environments? It's not straightforward. Well, with the Access solution, it's quite nice where we're able to accommodate seamlessly for both environments. Just deploy another connector for that given environment for what is appropriate and then move on. And we'll talk about that in a few moments. Lastly, before I kick things off to Faraz to go into the technical components of the solution, I just wanted to leave you for food for thought here. And this is a little quote that we pulled up from Gartner, and that is simply DMZs and legacy VPNs are designed for the network of the 1990s and become obsolete because they lack the agility needed to protect digital businesses. Thought this was quite poignant when you consider this entire architecture stack. Right? We do live in a digital mobile world where many of our end users, whoever they might be, are going to need access to applications and resources at any given point in time. They may be remote, heck, they may be on site, they may be somewhere in between. But the reality is to be able to be productive and to be able to reduce costs, it has to be able to have a manageable, simple, secure infrastructure to be able to do all of it. As a result, let's dive into how we solve all this problem. So I'm going to kick it over to my colleague, Faraz, and he's going to take you through the solution. Thanks, everyone.
Thank you, Randy. So enterprise application access comes in to address all these legacy traditional environments, traditional challenges. Enterprise application access is a more simpler, more secure way of accessing enterprise apps behind the firewall. It incorporates all the DMZ functionalities and offer it as a service offering. EAA, or Enterprise Application Access, can help enterprise streamline secure access while improving their security posture by providing clientless, application-specific remote access. Now, enterprise application will only provide authorized secure access to specific applications, but nothing else on the network. This ultimately creates an air gap between private applications and infrastructure, and the internet, which minimizes the attack surface and makes enterprise infrastructure invisible to the public. All that is required is an HTML5 compliant web browser, the Akamai Intelligent Platform, and the Akamai Enterprise Connector in the data center or virtual private cloud. The Enterprise Connector supports most hypervisors and containers and integrates with enterprise identity stores such as Active Directory and mutually authenticates with Akamai Platform over TLS. And we'll get into more of these details in our next viewer section. At the same time, the user authenticates using MFA, or multi-factor authentication is required, through a web browser over TLS with the Akamai Platform, and the enterprise identity store supporting single sign-on. Once securely authenticated, Akamai simply stitches together the two TLS sessions over Akamai Platform to provide access only to the authorized application on the enterprise network and nothing else. In turn, the enterprise application hosted behind the firewall is now accessible to remote workers and third parties with single sign-on and multi-factor authentication support through a web browser or mobile application without exposing the entire enterprise network and mitigated unrestricted layer movement across applications on the network. My apologies. In looking at the architecture, the service is comprised of three core components. The EAA Edge is where all the data components reside. The Enterprise Applications Management Cloud is where management and configuration of the access edges, applications, and connectors live. And third, and not the least, the Enterprise Connector, with each connector deployed such that it has direct reachability to enterprise applications behind the firewall and usually co-located with applications within your data center or cloud environment. The management cloud is a secure multi-tenant system that maintains all the configurations relevant to enabling secure application access for enterprise applications. The administrators interact with management system via portal to configure application access and to download connectors that need to be installed in the enterprise. All administrative access to the management portal can also optionally be secured via two-factor authentication. This connector will establish several mutually authenticated TLS 1.2 sessions with the management cloud and will receive configuration and application updates from this. In contrast, the EAA, or the Enterprise Application Edge, acts as a broker between a device sitting on an untrusted network and the configured enterprise application. In this fashion, the edge acts as the first line of defense between the untrusted network and an enterprise network. The edge receives configurations from the management cloud over mutually authenticated TLS secure channels. The edge forms a deflect before connect barrier for applications, providing protection against unauthorized users with robust access policies. This edge is actually configured to only receive HTTP or HTTPS traffic from an untrusted networks, and all the packets received from untrusted networks that corresponds to any other protocols will be dropped. Let's start to talk about the most important aspect of it, the enterprise connector. The enterprise connector that is installed behind the firewall and is hardened headless virtual appliance that has no UI, no CLI, and is cryptographically unique and does not accept any inbound connections. It proxies connections to internal applications and is built on an application delivery controller core, so it can support full ADC functionality, including load balancing, custom headers injection for single sign-on, URL path-based routing, authentication bridging, and content rewriting. The connector can support any virtual environment, including VMware, Hyper-V, or as a Docker container, or it could also live in any public cloud environment, including AWS VPC. Most enterprises will have some sort of VMware environment today, so this makes it easy for a seamless fit. This enterprise connector establishes communication with enterprise applications through HTTP, HTTPS, RDP, VNC, or SSH protocols. And in case of RDP, VNC, or SSH, it will actually translate those services into HTTPS, so these applications can be accessed from any modern HTML5 browser. Let's take a look, let's do a little bit deep dive into a connector functionality in the architecture. The connector actually maintains two different types of communication channels with the enterprise application service. The first one is the management channel. The second is the data channel. For management channel, the service actually relies on inside-out communication from the connector to various API endpoints exposed by the management plane. The connector communicates with these API endpoints to pull configuration data, Active Directory groups, and other user information, and share application health information. This communication is carried out over mutually authenticated TLS sessions. The application transactions may be WebSocket-based instead of request-response type setup, depending on the specific workflow. From this management channel information, the connector figures out which applications it's supposed to enable secure access to and what policies to enforce. Based on this info, a connector will initiate several mutually authenticated TLS sessions to Akamai data edges. These number of sessions depends on the load of the application and the connector. There is a minimum number that connector will start with and will create new sessions as needed based on the load. And if the load goes away, extra sessions will be aged out till the next batch of users shows up. The minimum, maximum, or the jump for the session creations are configurable values in the UI. Enterprise application access uses TCP optimization, where it can multiplex multiple user requests over a given session and perform header compression, which significantly reduces overall latency. The connector also has another session to the application. Let's see how it all works. If we summarize all of this and look at how it all works, then we'll start with the user. In order to get access to the application, the user simply needs a URL or an external host name. This URL will be configured through administrative portal, and just like with any other Akamai service, the application host name is CNAME to the service. When the user types in the application external host name, he or she will be redirected to Akamai Enterprise Application Access Edge. The edge will only accept TLS traffic for configured applications and those requests coming from authenticated authorized users. Anything else will be dropped. The Enterprise Application Edge first verifies if the user has a sanction ID in the Active Directory user database synchronized through Enterprise Connector. In this iteration, user request is part of the Edge servers, and authentication data is sent over to Active Directory over mutually authenticated TLS sessions originated outbound from the connector that also works as an LDAP client. For user authentication, not only can the connector act as an LDAP client so as to be able to authenticate users directly within Enterprise Active Directory, but the solution also easily integrates with Okta or Ping1, OneLogin, Active Directory, Federation Services, or any other generic SAML IDPs. Once the authentication is done, the Akamai Access Edge simply stitches together the two TLS sessions, one which is coming from user's browser and other coming from Enterprise Connector, and creates an application layer 7 pass-through to enterprise applications. The end result is end-to-end layer 7 connectivity between the user and the application without providing network connectivity. It doesn't require need to open any inbound firewall ports, no complex configuration, and no client software. This process is simply transparent to the end users since they can open up their browser, type a web address, authenticate, and get direct layer 7 access to the application. Let's put it all together. What you have just seen now is how the Access Edge allows for layer 7 connectivity from an end user to the applications behind enterprise firewall, whether hosted in company's own data center or in a cloud environment like AWS, and without needing to open any holes in that firewall just to provide remote user access. You've also seen how there is no client software to install, just a connector that sits in an enterprise environment that can be deployed on any virtual platform. Enterprise application access can authenticate users using the customer's, your own Active Directory domain, using NTLM or Kerberos-based authentication, and even integrate seamlessly with any SAML IDPs out there, for example, Okta, Ping1, or OneLogin. All the configuration is done in the Enterprise Access Management Cloud, while the Access Edge coupled with Enterprise Connector provides a secure data path to applications behind the firewall using a single login portal. Let's take a quick look on all the 6 aspects of secure access that Enterprise Application Access can provide. If users are not on the corporate network, they cannot pivot into other applications, and lateral movement is not possible, hence providing better security. Second one is no attack surface. Application access is possible only after successful authentication and authorization happens outside the network or application perimeter. There are no inbound firewall ports or IP address whitelisting needed. Apps are completely invisible, which eliminates the attack surface and DDoS threats. App segmentation. Users do not connect to the network, instead they connect to an application. And connection is always made on layer 7 application layer, and hence the network level segmentation is not required. Complete visibility and auditing. EAA Edge, as you see, sits in the data path and provides end user access logging used for compliance and audit purposes. Access logging, SSH auditing, and RDP video recording provides end user visibility that can further enhance the security. The Enterprise Application Access only brokers the connectivity between the end users and applications using public internet as a transport, where customers control and manage client and server certificates. So there is no requirement of client-based VPN altogether. No tunnel or a no client-based architecture. As we have spoken before, users can access any HTTPS, HTTPS application, Windows applications or Windows Server environments, or Linux applications using a plain HTML5 browser from any end device. Let's take a look at some of the key use cases the enterprise application access addresses. The first one is secure third-party access or partner access, just like Randy mentioned. It provides simple and secure third-party access or contractor access to enterprise applications, which mandates access on a per-application basis versus the entire network. It supports for web, SSH, and VDI RDP applications, and supports multi-factor authentication, single sign-on, and other internal application load balancing. Second is the cloud migration. With all the cloud adoption that we see today, the enterprise application access supports apps in any infrastructure as a service platform and enterprise data centers, allowing for effective migration of these enterprise applications to the cloud. It removes complex and brittle network architectures, including backhauling VPN traffic to central data center for authentication, reducing cost with cloud migration, and improve application access controls, and a single cloud-based solution with consistent policies all around all the VPCs. The third most common use case is the managed employees or your remote employees. Managed employees access to specific applications where they are never brought into the network and apps are never exposed to the internet. The employees now can access applications without requiring a VPN client, and it embraces a zero trust model for network and information security. The fourth and the last most common use case that we see out there that the EA addresses is merger and acquisitions. Merger and acquisition, it helps providing named user access to named application without merging networks. With Akamai existing performance and security add-ons, it can be integrated with enterprise application access to further enhance and accelerate the traffic out to these enterprise applications that sits behind the firewall. You could integrate EAA or enterprise application access with Akamai industry-leading WAF to provide a layer 7 deflection for all of these DDoS type of attacks. So why enterprise application access? Well, because you don't need any more appliances, you can deploy much faster and need a lot fewer people to solve a very complex problem. That ultimately means significantly lower operating expenditures. Enterprise application access also empowers enterprises to close off their firewalls and to hide their applications from the internet. That is a better security model than anything out there. There's zero inbound ports on your edge firewall and zero trust in the network. Third one is very simple and easy to set up, and it's delivered as a service, so there is no more appliances to deploy at the network edge, no need for a network segmentation like we discussed earlier, and enterprise can actually bring up any new applications under 30 minutes or so. Lastly, the enterprise connector works in any public cloud environment, so enterprises can freely deploy applications, AWS, Azure, Google App Engine, or wherever, and can consume those applications from anywhere on any end device within just the use of an HTML5 compliant browser.